6-5 talks about solving square roots and other radical equations. Your objective is to learn how to solve for x if x is under a square root or if x is by a square root. There are a couple of important things today. Your main idea is this: isolate the radical or the rational exponent term. The first thing I want you to remember is that in order to get rid of a square root, you would need to square both sides. It's the opposite. In order to get rid of a cube root, you would need to cube both sides. When squaring a binomial, make sure you write it twice so you don't miss anything. For example, if you have x plus 4 to the quantity squared, make sure that you make that x plus 4 times x plus 4 so you don't mess anything up. Number 4, when solving for an x squared problem, you might need to factor or use the quadratic formula. Now, if you don't want to use the quadratic formula and you don't want to factor, that just means you'll have to complete your square. Following problems I would consider the easier problems of today. We're going to, ready, step 1, isolate the radical. So that means I need to move this 3 to the other side. So I will get the square root of 2x minus 3 equals, what's 8 minus 3? 5, because I did 8 minus 3. Step 2, now that it's isolated, step 2, square both sides. Why would I square both sides? To get rid of the square root. Alright, so I'm going to do a square here around 2x minus 3. I'm going to put squared around my 5. Now squaring this is going to give you 2x minus 3. Squaring 5 is going to give you 25. Now let's solve for x. Okay, that would be step 3. So add 3, so 2x equals 28. Divide by 2, x equals 14. If you want to see if you did it correctly, do a check. Okay, plug in 14. Alright, so if you want to check, you would do 3 plus the square root of 2 times 14 minus 3 equal 8. Well, that's really 3 plus the square root of 25 equal 8, which is really 3 plus 5, which equals 8. For problem 2, I'm going to teach you kind of a different way than I have in the past of solving problem 2 that hopefully will make it a little more simple. This time we are going to have an exponential, a rational exponent, which means we're going to have a fraction in the exponent. So what I want you to do first is kind of just box off the parentheses and notice we need to get rid of this outside 3. So we're going to divide by 3 to start with. Dividing by 3 on both sides is just going to give you your parenthesis of x plus 1 to the 2/3 power equals, well, when you take 12 divided by 3, 12 divided by 3 is 4. Now, the way that I've taught it in the past is a little bit different, so what I'm going to do now is just encourage you to know, and hopefully you can understand this, that in order to untrap this x, I need to take this entire side, or the entire problem, to the reciprocal of 2/3. So I need to take it to the 3/2 power. Now, when I take x plus 1 to the 3/2 power, that loses this 2/3 power, or essentially it turns to 1, and you get x plus 1 equals, when you take 4 to the 3/2 power, you will get 8. What I need to be very careful with in explaining here is that when you do this with an even denominator, you are technically finding the square root. So you must use plus and minus with your 8. That is essential for you to remember if you're going to use my shortcut here. So if the denominator you use is even, use plus or minus. So now we have x plus 1 equals positive 8, and we have x plus 1 equals negative 8. Solve. Take away 1, x equals 7. Take away 1, x equals negative 9. Both of those should be solutions. It's a pretty simple check. We'll take 7 and negative 9 and plug them in. Let me get my calculator somewhere you can see it. That looks pretty good. So let's check 7. So we'll do 7 plus 1 to the 3/2 power. And that does not equal. Okay, so let's check it. So we'll do 3 times 7 plus 1 to the old power of 2/3. And we will get 12, so we know 7 is a solution. Very quickly, we will check again. Negative 9 plus 1. And we get 12, so we know that we did it correct. Now let's solve part B. The first thing I want you to kind of box off is the part that's trapping x. So I need to get rid of this 3 and this 1. So first we're going to take away 1. And this equation will now be equal to 24. So I bring down my 3, my 5th root of x plus 1, which is cubed, and it equals 24. Divide by 3 on both sides. Please bring down, now watch what I'm going to do here. I'm going to bring down x plus 1, but I'm going to bring down 3/5. And that will equal 8. Okay, what students have told me in the past is that when it's a fractional exponent like this, they would prefer, instead of giving each side a power of 5 and then cube rooting both sides, what my students have told me in the past that they like, and they have found simpler, is to simply take 3/5 and do the reciprocal of 5/3 to both sides. So this 5/3 and this 3/5 are going to cancel, and you will be left with x plus 1 equals. Now, 8 to the 5/3 is 2 to the 5th power, because the cube root of 8 is 2 to the 5th power. But if you don't know that and you're not traveling on in mathematics, I guess it's not essential. 8 to the 5/3 power is 32. If you are traveling on, though, in math, you need to understand why 8 to the 5/3 power is 32. Okay, this is not even, so I do not have to use plus or minus on my 32. Take away 1, x equals 31. Let's try that one more time. This 2 is on the outside, and we need to get rid of it, so we will divide both sides by 2. This side will become a 4 when you divide by 2. So now we have x plus 3 to the 2/3 power equals 4. Again, students in the past have told me to untrap x, what they like to do is just take the reciprocal of 2/3 and make it 3/2. You could make it the cube root and cube both sides, but this is how they like to do it. So they said that 3/2 does cancel at 2/3. So you get x plus 3 equals. Now 4 to the 3/2 is really the square root of 4, which is 2 cubed. So we better get 8, but we will prove it on our calculator. In case you don't necessarily understand that, you do need to make sure that you can at least use your calculator to get 8. So 4 to the 3/2 power is 8. Take away 3. Oh, and I need to be very careful. See how this was even here? The 2 is even. I need to use a positive and a negative 8. So I actually have 2 solutions, don't I? I have x plus 3 equals positive 8, and x plus 3 equals negative 8. Solve each one. Take away 3, x is 5. Take away 3, x is negative 11. When you have 2 answers like this, and really anytime you have any answers, you should check them with the original. So I'm going to check with 2 parentheses x plus 3. So 5 plus 3 to the, what was the power up there? 2/3 power. I got 8, which was good because that's what it equaled originally. And now I'm going to replace x with that negative 11. Double check it with the original problem. I get 8 again, so I know that I did it right. Problem 3. For meteor crater in Arizona, the formula D equals 2 times the cube root of the volume over 0.3 relates the diameter of the rim to the volume in cubic meters. What is the volume of this meteor crater? All values are approximate. So we have this crater that was made, and you have the entire circle, and they're telling us that the diameter of your circle is 1.2 kilometers. But this problem is in meters, so we have to convert by multiplying that by 1,000, so we can convert it to meters. Multiply that to meters, so times 1,000 equals 1,200 meters. That's the first step. We need to figure out what the volume is of this particular problem. So let's write our formula down. And now let's plug in the D that we have. Moving over, I'm going to divide by 2. So I get 600 equals the cube root of volume divided by 0.3. Now I have to get rid of the cube root, so I'm going to cube both sides. Now when you cube 600, you're going to get 216 with 6 zeros. And over here, you're just going to get V over 0.3. Okay, and that came from cubing both sides. The next thing I'm going to do, follow it up. I'm going to multiply both sides by 0.3. Okay. Multiplying 216 million by 0.3 will give us 648 0 0 0 0 0. So 64,800,000 meters cubed for the volume.